Hey there, I'm Ken. This is Canadian Retro Things. Happy Septandy. So what am I going to do to start off Septandy? Well, I am going to continue working on the concept of the game that I have for the electronic book. So when I made the original concepts for the game that I'm thinking about doing or trying to do for this book, well, I did a very quick and dirty program about how to read the 12 keys on this. Basically, it was just 12 if-then statements. Well, computers are capable of so much more than that. All you have to do is apply a little bit of math to that. Well, yeah, math is hard, so, well, we're going to see what I can do today. Can I create some sort of a loop or algorithm or something that will be able to use fewer lines of code to read the 12 keys on here? I'm hoping so. So let's jump into doing that. The first thing I have to do is just take a look at what the values are when the keys are pressed and try to find some pattern in there and see if I can make that pattern into some sort of repeatable loop reading program. So, yeah, let's get to it. So just as a quick refresher, we're taking a look at some of the footage from the last video, which if you haven't watched it, you can just see how I came up with this to do this little bit of proof of concept here. But to get it to read the electronic book, I used a bunch of if-then statements. As a matter of fact, I used 12 of them for the 12 keys that are in the electronic book. And I mean, it works. But is there a better way of doing that? Well, only math will tell. So that's what I'm going to try to do today. All right, so I have a spreadsheet here with the actual values that are come up when you hit the keys, whether it's on joystick 0 or joystick 1. Now I did do the experiment in the last video where I figured out that these are the actual numbers that I get off of my electronic book, which are pretty similar to the ones that were in the Rainbow magazine, but not exactly the same. So that's why in the previous video for my if-then statements, I used a range of numbers for each one. I'm not using an exact number because, well, 40-year-old components and things may wander just a little bit. So you look at this list and you can see the numbers are all over the place. There's not a lot of consistency for how the numbers go with the key that you're pressing. So the first thing to do is put these in numerical order. All right, so here we go. Now, as you can see, in ascending order, starting with the value for joystick 1, moving into the value for joystick 0, you go 10, 11, 12, 9, 8, 7, 4, 5, 6, 3, 2, 1. So as you can see, it seems to be in 4 groups of 3. So looking closer at this spreadsheet, you can see that the 10, 11, 12 and 4, 5, 6 are pretty much the same numbers, just on different joystick ports. Same with 9, 8, 7 and 3, 2, 1. So because there's 2 groups there that are similar, it's basically 2 groups of 2 numbers. So I want to put in a range that will read either the, for instance, the 10 or the 4 key. They're both 9, so. So as you can see, if I go for a range of 7 to 16 on there, it'll read the 9 key there, and it'll read the 9 key there, depending on which joystick port it's reading. So interestingly enough, if I go up 10 from there and go 17 to 26, it'll fall with the 22 falls right into it, which I can also do down here. And then I can go 27 to 36. So I'm just moving all of the numbers up by 10, which works well for being able to do what I want to do here. So now if you look closely at these, 4 is 7 to 16 and 10 is 7 to 16. 10 is 6 higher than 4. Well, we move down to 5, which is 17 to 26. 17 to 26, well, that's also 6 higher. And this one is also 6 higher to its corresponding number. 6 higher, 6 higher, and 6 higher. This means that the second half of the keyboard, everything that's read on joystick port 1, is all a key that is 6 higher than the key that is read on joystick port 0. So that brings to mind some interesting ideas for some sort of a repetitive pattern that I could use to make this work. Okay, I have been sitting here thinking about this, and I think I've come up with a way of being able to do this. So first off, we have to have some variables. So I'm going to go with P1 and P2 will be the joystick values. Now JP is going to be a number that will indicate whether if it reads joystick 0 or 1. R1 will be my range value that I am going to be figuring out here. Now, when I originally thought about this, I was going to use R1 and R2, but I'll explain that later why I'm only going to use R1. A will be the number that is read by the joystick port, either 0 or 1. KP will be the key pressed. That'll be the loops of the keys that could possibly be pressed. And C will equal the actual key pressed. So to start this program off, the first thing I'm going to have to do is read P1, which will be joystick 0, and P2, which will be joystick 1. Now the next two lines that I put in here is that if P1 is greater than 0, that means a value was read on joystick 0, which then we will set JP to 0. And if P2 is higher, or got a value over 0, then JP will be set to 6. And you remember that the difference between the keys, here we'll just look at this again, each of these keys is always 6 higher than the corresponding 0 to joystick 0, joystick 1. It's always 6 higher on the key for the corresponding same range of numbers. Next thing, we will put R1 as 7, which is our starting value of where to read. So if we go back to our thing here, we can see that 7 to 16 is the first number that we read. So I'm just using R1 is the first number. The next thing I'm going to do is set the number that is read. It's going to go into one variable, so it's not going to matter whether it's joystick 0 or joystick 1 that the number is read on. It just matters what the number is. So if it's JP is equal to 0, then we know here that JP was set to 0 when there's a value for joystick 0. So then A will be set to whatever the number P1 was set to. Similar, if it's 6, then it'll be set to whatever the number P2 was set to. The next part of this is our first loop. So we're going 4 to 6. So those are the values for the keys 4, 5, and 6 here. So the 9, 21, 9, 21 or 32, 9, 22, and 33. So that's the ranges of 7 to 16, 17 to 26, 27 to 36 on both keys. So on the first loop, it checks whether A, which is the number that was read into from a key press, is greater than R1, which right now is 7, or less than R1 plus 9, which would be 16. So a range between 7 and 16. If it is, then it goes to a different part of the program. Otherwise, it adds 10 to that value and goes to KP being 5, and we're reading 17 to 26, and so on and so on. So if that doesn't work, then we break out of that, and then we have to set the next R1, which will be 37. This will be for the next loop. Oops. So this loop is a little bit different in that it's going from 3 to 1 with a step of -1, which means it's counting backwards. And then starting at 37. So at 3, it's 37 to 46. And then at 2, it's 47 to 56. And so on and so forth. And then if none of that happens, then go to the start again because no key was pressed. Now the line that we're going to here, if a value was falling into that range, is where C, which is our actual key pressed, will be equal to the key press, which is the loop number, plus JP. That's the whether it read joystick 0 or 1. So as you can see here, if it's, say, 3, then the value of JP is 0, so the key press will be 3 plus 0, which will be 3. But if it was 9, then it would be key press 3 plus 6, which is then 9, which is the actual key that was pressed. And from there, we go to the rest of the program to do whatever it's supposed to do. I hope that is as clear as mud. So now I'm going to try and type this into the computer and see if I can make some changes to make it a little bit shorter. It's a lot of little lines there, so I should be able to shorten that up quite a bit. And we'll go over it in the computer and see what I came up with. I've finally got something programmed into my color computer that hopefully is going to work. Now, this took me a lot longer than it should have, and well, I'll just point out the reason when I get to that part of the program. But I've got the color computer screen up there, and I've also got that original document that I wrote out. So I'm going to compare the two on how I've shortened this program up a little bit. Now, as you can see, the first 4 lines there, which are putting P1 and P2 values in and then checking what it is and setting the JP value, which is the joystick read value, whether it's reading joystick 0 or 1. I've combined that all into one line. So just the semicolons, P1 and P2, are set to joystick 0 and joystick 1. Then if P1 is greater than 0, JP equals 0, else JP equals 6. So I took out that second if-then line, even though this means that if a button isn't going to be pressed, then JP will be set to 6, but both P1 and P2 will be 0, so they'll be out of range, so that won't affect anything. So on line 50, I combined a couple of lines there. The next 3 lines are actually all combined because 50, R1 equals 7, so I'm setting the value of R1. And then I'm saying that if JP equals 0, then A will equal P1. So that means that if JP is set to 0, then A, which is the number read, will be what is read on joystick P1, else it's going to be set to what is read on joystick P2. So again, if the test subject is that no button was pressed, then both P1 and P2 are 0. That means that A will just be set to 0, which will be out of range of all of the tests that are coming up. And the next part of the program is that I am starting the loop. I've combined the next couple of lines here. So I'm starting the loop at testing keys 4 to 6, which would also test keys 9 to 12 if it's read from joystick 1. And you may be wondering why I did that and didn't start with keys 1 to 3. Well, that is because the R1 value is the lowest on keys 4 to 6. So I'm going a numerical value of the R1. So testing whether it's between R1 and R1 plus 9. If not, then it just continues with the program. If it is, it jumps forward to line 150. So the next line just adds 10 to R1 and then goes back to test. So if it starts at 4, R1 is 7, it tests that, then it goes to 5, R1 now becomes 17, so it's now 17 to 26 that it's testing, and so on and so forth. Now if you look at the program that I wrote on the side there, the next thing should be setting R1 to 37, but I didn't do that. I just jumped straight into the next loop because I figured out actually when the first loop ends, R1's already set to 37, so I don't have to reset it. So the next line is line 90, which is a little bit different because I'm counting backwards from 3 to 1 by using the step -1 loop. Now, why did I do that? Well, because the R1 value is going in reverse from 3 is the lower number, 2 is higher, and 1 is the highest. So I had to count backwards there. So, or I could have actually done it with setting the R1 value higher and negating or subtracting a number from it, but this way I got to take out that R1 equals 37 because that's what the R1 is already set to. So again, it tests it. If it's in the range, it goes to 150. If not, it adds 10 to it and then goes back to the loop again. Once it completes that loop, if it doesn't find anything in there, then the next line would be go to 40, which just goes back to reading the joystick ports again. Now the 150 that I put in is where it sets C, which is the actual key pressed, to the KP, which is the loop number, plus JP, which is 0 for joystick 0 or 6 for joystick 1, because those numbers are 6 apart. And then it goes to 300. This is where I screwed up. I actually had it going to 400, which completely bypassed just about everything for testing the C value and printing out that you pressed a number, which just was a complete mistake on my part. Okay, I have the electronic book hooked up. Time to test to see if the program is working the same way as it did before. Yes, it is. All the numbers appear to be working. Perfect. So there we go. That looks like it worked. Yeah, this part of the program is definitely a little bit shorter. I think a little bit more elegant. I'm not sure whether it actually works any quicker or not, but yeah, with a few lines less code, I think it's looking pretty good. So it just goes to show that math can work. So let's try putting this into that final little game concept that I did before. I've got definitely some plans coming up for another video about how I'm going to actually do this game, but let's throw this little algorithm into the actual little bit of gameplay that I had made and see how well it works there. All right, I've added this little algorithm into the little game concept that I made earlier. So now let's see if, as you can see, this is the entire thing. Let's see if it works. Yep, looks like it works just fine. There we go. I have 4, monster has 7. Hit, hit, he killed me. Let's try that again. I have not been getting lucky with the random rolls. This is 4th time I've done this. There we go, finally. Okay, so I have 11, he has 2. That should be easy to beat him, but first we'll try running away. There we go. Now we will fight him, and I win. And the monster is no longer on that space, so I would call this a success. That little algorithm that I made up definitely saves a bit of programming space rather than 12 if-then statements. Yeah, I'm happy with it. All right, well, that definitely worked. I mean, I am so happy that all that math that I did in high school and university did not go to waste. It all came together by helping me make this program. Now, I'm not going to say this is the final iteration of how I'm going to be reading the keys on the electronic book. As a matter of fact, I am talking to some other people about more knowledgeable people than me about ways that maybe would be easier to read the keyboard. I just thought I'd give it a shot myself, and we'll see what happens. But I'm really happy with what I did here today because it's a shorter program, easier to type in, and yeah, it works. So that's the important thing. Now, of course, this being Tandy, I am going to have to do a little bit more with this program. So I do have many ideas of how I want to do this, and I'm going to start actually setting up the game itself. Hopefully I'll get another video out this month because, of course, Tandy, the best time to program on your Tandy computer. But, of course, we've reached that time of the video where I have to say thank you to my patrons because their names are rolling by on the screen right now. So big thank you to everybody that supports me on Patreon. If you are interested in helping out the channel, then the link is down in the description. If you do, then you will get early access to my videos. You could get your name up on the credits. You could even have your name at the beginning of the video. Check out my Patreon if you're interested. All right, well, and yeah, I just have to say thank you for watching, subscribing, and liking this video because, of course, everything and anything people do is helpful, helps get these videos out to people, and just makes it a lot of fun and worth making. So thank you very much, everybody watching this, and I will see you next video. Happy Septandy.